Constants and literals. Constants. Like a variable, a constant is a data storage location used by the user's program. Unlike a variable, the value stored in a constant can't be changed during program execution. C has two types of constants, each with its own specific uses. Are the examples for literal constant. Symbolic constants. A symbolic constant is a constant that is represented by a name, open bracket, symbol, close bracket, in the program. Like a literal constant, a symbolic constant can't change. Whenever the user needs the constant's value in the program, he can use its name as would use a variable name. The actual value of the symbolic constant needs to be entered only once, when it is first defined. Symbolic constants have two significant advantages over literal constants. Suppose that the user is writing a program that performs a variety of geometrical calculations. The program frequently needs the value of pi, open bracket, pi, close bracket, minus 3.14159 for its calculations. The value of pi is constant. For example, to calculate the area of a circle with a known radius, the user would write the following code. The asterisk is C's multiplication operator. Thus, the first of these statements means multiply 2 times the value stored in the variable radius and then multiply the result by 3.14159. Finally, assign the result to the variable name area. If, however, the user define a symbolic constant with the name pi, open bracket, n, close bracket, and the value 3.14, he would write the following code. The second advantage of symbolic constants become apparent when the users need to change a constant. Continuing with the preceding example, the user might decide that for greater accuracy, the program needs to use a value of pi with more decimal places. If the user had used literal constants for pi, he would have to go through the source code and change each occurrence of the value from 3.14 to 3.14159. With a symbolic constant, he needs to make a change only in the place where the constant is defined. The rest of code would not need to be changed. Defining symbolic constants. C has two methods for defining a symbolic constant. The first way to define a symbolic constant is the hash define directive is used as follows. This creates a constant named CONSTNAME in capital with the value of literal. Literal represents a literal constant as described earlier. CONSTNAME in capital follows the same rules described earlier for variable names. By convention, the names of symbolic constants are uppercase. This makes them easy to distinguish from variable names, which by convention are lowercase. For the example, the required hash defined directive for a constant called pi would be, note that hash defined lines don't end with a semicolon. Hash defined statements can be placed anywhere in your source code, but the defined constant is in effect only for the portions of the source code that follow the hash defined directive. Most commonly, programmers group all hash defined statements together near beginning of the file and before the start of the main function. How a hash define works. The precise action of the hash define directive is to instruct the compiler as follows. In the source code, replace const name with literal. The effect is exactly the same as if the user had used the editor to go through the source code and make the changes manually. For example, in the following code, the instances of pi in the second and third lines would not get changed. Note that hash define lines don't end with a semicolon. Hash defines can be placed anywhere in the source code but they are in effect only for the portions of the source code that follows the hash define directive. Defining constants with the const keyword. The second way to define a symbolic constant is with the const keyword. Const is a modifier that can be applied to any variable declaration. A variable declared to be constant can't be modified during program execution, only initialized at the time of declaration. Literals. The constants refer to fixed values that the program may not alter during its execution. These fixed values are also called literals. Constants can be of any of the basic data types like an integer constant, a floating constant, a character constant, or a string literal. There are also enumeration constants as well. Integer literals. An integer literal can be a decimal, octal, or hexadecimal constant. A prefix specifies the base or radix. 0 small x or 0 capital X, ox for hexadecimal, 0 for octal and nothing for decimal. An integer literal can also have a suffix that is a combination of U and L for unsigned and long respectively. The suffix can be uppercase or lowercase and can be in any order. Floating point literals. A floating point literal has an integer part, a decimal point, a fractional part, and an exponent part. The user can represent floating point literals either in decimal form or exponential form. While representing using decimal form, the user must include the decimal point, the exponent, or both, and while representing using exponential form, he must include the integer part, the fractional part, or both. The signed exponent is introduced by small e or capital E. Character literals. Character literals are enclosed in single quotes, example, open quote, x, close quote, and can be stored in a simple variable of char type. A character literal can be a plain character, example x, an escape sequence, example, open quote, backslash, small t, close quote, close bracket, or a universal character, example, open quote, backslash, u, 0 to c, 0, close bracket. There are certain characters in C, when they are preceded by a backslash, they will have special meaning and they are used to represent like new line, open bracket, backslash n, close bracket, or tab, open bracket, backslash t, close bracket. Here the user have a list of some of such escape sequence codes. String literals. String literals or constants are enclosed in double quotes. A string contains characters that are similar to character literals, plain characters, escape sequences, and universal characters. The users can break a long line into multiple lines using string literals and separating those using white spaces.